is my Physics 2211 Lab 1 Constant Velocity. So here's an overview of what I'll be talking about. So I'll start with my introduction, including the purpose, and then move on to the physics principles behind the experiment, including the theory and diagram, along with the experiment, the computational model, as well as analysis of errors, similarities, and differences. And then I will answer the what if and what does it mean questions asked in the lab instructions. Purpose of this lab is to basically observe and analyze the motion of an object that is moving at constant velocities. That means that it is moving at the same speed without a change in direction. The aim of this lab is to use techniques such as video analysis, mostly tracker, the application, to extract the object's position and corresponding time data. And based on this data, the purpose of the lab is also to extend and construct a computation model that can accurately predict or describe the observed motion using physics principles such as the second law of motion by Newton. Here's a brief preview of the main results. So on the top left, you can see a graph made from the tracker application. And on the bottom left, we see the position versus time graph made from the GlowScript application. Here are some physical principles that I feel are important in this experiment. Newton's first law, his second law, the steady motion, also known as constant velocity, and iterative forecasting, also known as using a computational procedure to find and predict future motion. As you can see by the diagram made here, the pink can is rolling along the floor at a constant velocity due to the net force acting on the can is zero, since it gets canceled out with the normal force and gravitational force having equal pull. And since there's no force to the left or right, there will always be a constant velocity acting on the can. In this case of the can moving at a constant velocity, this implies that the speed and direction of the can remains unchanged. This means that the can's acceleration is also zero. Now, according to Newton's second law, which a version of can be seen on screen over here, which is the formula, the net force acting on the object must also be zero. So when this part is zero, F net over m, you can see here there's no addition to the initial velocity vi. So when this is 0 times 0, it'll be vi plus 0, which will give you vf. So the initial velocity will always equal the final velocity. Therefore, the can will move at a constant velocity of the same speed and same direction. The system can be considered as the can, and the surroundings can be considered to be the floor that the can is on. So as you can see, when I play the video, the center of mass shifts equivalent distance to the right, implying that the object is moving at a constant velocity. I had to tilt the axis slightly clockwise. I also chose to, since the object was moving from left to right, I chose to have my axes so that the positive direction would be to the right, and that is why I had a positive correlation between the time and distance from the origin. For similarities in this project, they both had the same initial velocity, and the velocity for both of them were in the same direction on the coordinate plane. But as for differences, the experiment done and used for tracker, there was friction, which was inevitable, even though it was tried to be minimized. There was nothing that could really happen when the can was rolling across the floor, and the velocity would start to decrease over time. For the what if and what does it mean questions, which was discussed in the lab instructions. So if I were to flip the axes, then instead of obtaining a positive relationship between the displacement and time, I would now receive a downward swapping the graph, which would indicate a negative relationship between displacement and time. As for how many pushes and pulls were added together to give us a net force of zero, in this case, only the normal force and the gravitational force acting on the object would be canceled out, since there is no force to the right or left of the object.